Alright, so here we're looking at a permutation where we have 8 things and we're trying to arrange all 8 of them in order. But it's a little different because some of the items are identical. There are 3 white flags that are all the same, 3 red flags that are the same, and 2 blue flags that are the same. So just to illustrate, if we had 8 flags and they were all different colors, we would just say we had 8 items and we're trying to arrange all 8 of them in an order. How many ways can we do that? And you would just do 8 permutation 8 and get that answer. But here's an example of what we have. And I just made one of the arrangements you could have, which would be 3 white, 3 red, and 2 blue. In a different order, but technically the same signal that you're showing to whoever's looking at your flags. If you swap the 2 red flags, and 8P8 would count that as different, but really this is the same signal. These 2 blue flags are identical, so if we put the one up before the other, it doesn't really change the signal, even though technically the flags are in a different order. So hopefully that makes sense. That's why we can't just do 8P8, because we have some repeat identical items. 3 white flags that are the same, 3 red that are the same, and 2 blue that are the same. So what we have to do is divide out by, we have to use this formula here where we divide by the number of things that are the same, so it cancels out those different combinations that are actually producing the same signal. So let me scroll up here. You take the number of items that you're arranging, which is 8, and then the factorial of that is what goes on top, and on bottom just divide by the factorial of the things that are repeated. So like we had, 3 white flags, so it'd be 3 factorial here, and then we had 3 red flags that are all the same, so you're dividing by 3 factorial for those 3 red, and then we're dividing by 2 factorial also for the 2 blues that are duplicates. And we're dividing to cancel out those signals that are actually look exactly the same, even though the flags are in a different order. They're the same color flags, so can't really tell that they're in a different order. So we have 8 total flags, and there were 3 white ones, there were 3 red ones, there were 2 blue ones, so we had to divide by the 3 white, the 3 red, and the 2 blue factorials of those, and there's 8 total. And so I'm just walking through this, help me solve this that comes with the problem, trying to explain it, but I think it's laid out here pretty good, so I wanted to use it. Alright, and from here the help me solve this actually has some shortcut math that you can do, but you could go ahead and type this into your calculator straight from here and get your answer. But what they're noting is that 8 factorial is going to be all the way down 8 times 7 times 6 times 5, 4, 3, 2, 1, and that's going to cancel out with some stuff on the bottom. I wasn't sure what they were looking for there, but so when the 3 factorial cancels out on top and bottom, you have 8 times 7 times 6 times 5 times 4. I think this is kind of a complicated way to explain it. They're just showing how you can reduce a bunch before you get to the answer. Kind of threw me for a loop. I would stop right here, and you can do that on your calculator. 8 factorial on top gives you, so like I was saying, you can just do the 8 factorial on top, and then the 3 factorial, the 3 factorial, and the 2 factorial. Multiply those together, you get 72, and then that would reduce down to 560 different ways you could rearrange these flags that have the 3 of the same color, 3 of the same, and 2 of the same.